Hey everyone, it's Mrs. Mays. You're here to learn some chemistry, and today we're talking about making solutions. So let's get right to it. In fancy chemistry words, a solution is made from a solute and a solvent. So what we mean by this is that we could create a homogeneous mixture. A homogeneous mixture, remember, is the kind of mixture that's so well mixed that you can't tell one part from the other. And it's consisting of two or more substances. The solute, S-O-L-U-T-E, is the part of the solution that is being dissolved. It's usually the lesser amount in your solution, not always, but most of the time it's the smaller amount, and it's considered to be the thing that is getting dissolved. Whereas the solvent is the part of the solution that is doing the dissolving. This is the part that dissolves the solute. It's usually the greater amount of the two substances or more substances. So the solvent is doing the dissolving, and the solute is the thing being dissolved. That's it. Here's our first example. 1 teaspoon of sugar, called sucrose, is dissolved in a cup of water. So just picture that. You stir some sugar into some water. Let's identify which component is the solute and which component is the solvent. Remember, the solute is the thing that is being dissolved, so in this case that would be the sugar, right, or the sucrose. And the solvent is the component that's doing the dissolving, so we're dissolving the sugar in the water. Water acts as the solvent. Water is such a good solvent that it's sometimes called the universal solvent because it can dissolve so many different types of things. And that makes water really important for life as we know it on Earth. So let's have a look at how ionic compounds actually dissolve. So the first thing that has to happen is that we would add the solute to the solvent. In this case, the solvent is water, and the sodium chloride is the thing being dissolved. Let's look at the microscopic view. Notice how the water surrounds the ion sodium with the opposite charge. More particles get surrounded by water, and the entire salt particle breaks into pieces. That's what it means to dissolve, that it's broken apart into ions, and each of those ions gets surrounded by water molecules. That's called the hydration shell then, and that keeps the ions from sticking back together because now they're completely surrounded by water. This all has a lot to do with polarity, like we learned before in chemistry. Polar molecules are attracted to other polar molecules. And they're also going to be attracted to any particle that is electrically charged. Like we just saw in the example, the polar molecule water was attracted to particles like sodium ions or chloride ions that break apart in the water. On the other hand, if you had a nonpolar substance, then it would not interact very well with water because it doesn't have any charges. Nonpolar substances would only be attracted to other nonpolar substances. So it is said that like dissolves like. In other words, a polar substance dissolves another polar substance, but nonpolar substances will only dissolve other nonpolar substances. Like dissolves like. Polar and nonpolar do not dissolve in each other because they're not the same. Water is considered to be, what do you guys think? Do you remember? Is it polar or is it nonpolar? Think way back, before Christmas. We learned that water is considered to be a polar molecule, right? Because it has an uneven distribution of the electrons in that molecule, an uneven distribution of charge. Therefore, it is considered to be a polar molecule. There's a positive region and there is and negative region in the water molecule. So let's take a closer look at that. Here's our water molecule. Notice that the side with the oxygen on it has a higher concentration of electrons, so it's going to be more negative, and then the side with the hydrogen atoms will be more positive because it will have a lower concentration of electrons in the molecule overall. Oxygen's kind of an electron hog, so water is a polar molecule. Because it's a polar molecule, then it can dissolve all kinds of things, especially ionic compounds. And remember, ionic compounds are crystalline or crystal-like. So you can see the charges here that we looked at before, the chloride and the sodium, those will get broken apart because of the charges, the uneven distribution of charge in that water molecule. The crystals of ionic compounds are held together by charges that are attracted to one another. So when we overcome those charges, or we surround those charges with other positive and negative charges, then we can get the substance to dissolve in water or in any other polar substance. So let's take a closer look at dissolving two substances, salt and sugar. So the first thing we'll need to do is add some salt into the water. There we go, shook some salt in. And now let's see, one of the properties of a solution is that it would conduct electricity. So I connected my battery and my electrodes, and what do you know? The light bulb turns on. The more salt I add, the brighter the light bulb gets because I'm adding more charged particles to my solution. So if I remove the salt, my light bulb dies because there's no ions, no charged particles to carry the electrical current. So let's get our light bulb back on. And let's see what our conductivity looks like now. That's a lot better. So I have a concentration of salt. Let's see the value, 1.13 moles of salt in every liter of water. So we'll add some more. What do you suppose happens if we add more water? Now we would dilute our solution, right? And our light bulb gets dimmer. Okay, let's drain some water out. Go back to where we started from. Okay, whoops, a little too far. Add a little more. There we go. Now I'll put some salt back in to get up to about 1.3. Get my light bulb shining nice and bright. Oh, almost 1.5. Okay, what if we evaporate some of the water? So the salt will remain in the tub, but we're going to evaporate some water. What happens to the concentration? Look at the chart over on the, oh, now I'm below the solution. There we go. Look at the chart that's over on the right. It's showing us the concentration of the ions, and what we're looking for is that what we can see is that the concentration of the salt increased because I let some of the water out without changing the amount of salt that was in there. So if we add water, the concentration decreases. If I take away some of the water, then the concentration increases again. And if there is no water, then there's no light bulb, right? And if there's no salt, there's also no light bulb. Okay, this time let's add sugar. Here's my sugar shaker. So we're going to pour some sugar in, and I want to see my value. Let's look at that concentration. So I have 0.1 molar. Let's get a lot of sugar in there. Oh, that's all the sugar I have, 0.29 molar. All right, not the same amount as salt. My light bulb, though, is not lighting up. Well, what I know about sugar is that it's not made of ions. Remember sugar's formula? If we were just looking at, say, glucose, that's a simple sugar, C6H12O6. Remember, this is a covalent compound. All of these atoms are sharing electrons, not transferring electrons. So there's no charged particles in my sugar. That's why when it dissolves, it doesn't make charged particles. The water can still surround the sugar, but it doesn't pull it apart into charged particles. So let's take a look at the microscopic view of dissolving sugar. Okay, here's my sugar. Let's add our sugar molecules into the water solution. And they bump around in the water until they're evenly distributed throughout the solution. There we go. So now they're evenly distributed. Let's look at what it looks like in the water. So here's my water molecules all bumping around. We're looking in real close now. I'm going to put some sugar in there, and they just shift around until the water particles completely surround each molecule of sugar. This one's showing us sucrose, which is more likely the sugar that's in your sugar shaker at home. The one you put on your Cheerios and stir into your iced tea, that's sucrose. So these sugar particles got surrounded by water molecules because sugar is a polar molecule and water is a polar molecule. Like dissolves like. Now let's reset and let's compare that to putting salt in the solution. When we put salt in there, it just gets torn apart. Those particles that were charged get surrounded by water molecules, and that particle of salt completely got ripped apart, whereas the sugar did not. So now you know how to make solutions. You'll need to keep track of what thing is the solute, what thing is the solvent, and remember, like dissolves like. When you do your lab, you're going to explore what substances will dissolve in polar things like water and what would dissolve in something non-polar like hexane. All right, see you guys later.